what would a typical graph of stress versus strain look like? So let me start a sketch of a graph here. And given the fact, so we have, let's see, I'm going to put stress here because this says stress versus strain. So that means stress should be the vertical axis there, and strain should be on the horizontal axis, the independent variable. So the way that's phrased actually tells me how those axes should be oriented there. The fact, now let's see, we said stress is what you do to a system. In that sense, when I said stress versus strain, like this always seems a little weird to me. Like, shouldn't I do strain versus stress? There's no reason I couldn't, but that's what the question asked for, right? And I think it's commonly what you see in textbooks, which is why I'm doing it. But what I find a little bit weird is I said this is in the independent variable place, and philosophically that's weird because usually we think of the independent variable as a thing that I control to make whatever's on the dependent variable axis happen. And in this case, I'm kind of doing the opposite because I look at a stress as the thing that I do and strain as the response of the system. I'm not sure exactly why that is. Maybe somebody else can tell me. But anyways, the key concept we have, though, from the key concepts page that can start this off is the fact that strain is proportional to stress. And we had that kind of question of like, well, could you also say the stress is proportional to strain? The answer was yes. Either way, the graph looks the same. It's going to just, that implies it's just going to be linear, so it would be a line. But, okay, that's a pretty good answer to this. And in that sense, if this question had said, what would it look like below the elastic limit, this would be perfect. But then there's reality, and that's the part where maybe I don't necessarily have like one unique perfect answer to this question. At some point, that linearity is going to break down. It turns out what tends to happen is once you go past that point, the object will actually start to like deform more for not as much required applied force. And so the way that winds up looking is the slope kind of diminishes. And then, so like in this graph, I could say, okay, that point where that starts to occur, that's really the elastic limit. And then, there could be, like, I've seen different pictures of this for different materials, sometimes in engineering textbooks and such. There could be different things that happen. Like there could be a point where, okay, this is where like maybe permanent deformation happens. That's one possible example. There could also be a different label that could be there depending on what kind of material we're talking about. Is there could be a fracture point. So different materials will respond differently. It could be permanent deformation then followed by a fracture point. So there's different things that I've seen that can happen there. Exactly where that occurs can also depend on the material. For some materials, you get to the elastic limit and permanent deformation and or fracturing pretty much happens right away. Others, you have maybe a much larger region of permanent deformation where if you let the system return to where it originally started, to where it was kind of at equilibrium, there would be no permanent deformation even though you were well outside the elastic limit. We've done experiments in our lab with some bungee cord and some elastic bungees, that is. And it turns out for them, this elastic limit comes on pretty quickly. And then they can be stretched a whole lot more. And if you kind of tug on them, you can actually feel it. But we've done experiments where we've drawn graphs of this, and we've seen that, you know what, this linear region winds up being really small. And then this region winds up being like super huge, where it's like well beyond elastic limit, but still not at breaking or permanent deformation. So anyways, let's check out the general answer there. It looks like we're mostly in agreement, even though we've gotten this big discussion about reality there. There may be some cool internet searches you could do on that if you wanted.